Welcome to Know-how. In this video, we will look at resistors connected in parallel and what the equivalent resistance is. Let's look at a circuit with a voltage source V and then two resistors connected in parallel across it. So we have R1 and R2 connected between the nodes A and B. B is ground. So if you look at the voltage dropped across both the resistors, it's the same and it is nothing but V. So VR1 is V and that's also equal to VR2. So now a total current I will flow into the circuit I, but it would split into two places. So there would be I1 flowing through this branch R1, I2 flowing through the branch R2. Now if you write equations for I1 and I2, I1 would be the voltage dropped across R1 VR1 over R1, which is nothing but V over R1. And then I2 would be VR2 over R2, that is V over R2. Now we know that if you apply Kirchhoff's current law at this node A, so we know that the current going in I would be equal to I1 plus I2. Now I is V over R equivalent, the equivalent resistance seen between these 2 points here. This is R equivalent, which would be equal to I1 is V over R1 plus V over R2. So R you could write 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So this would, it's not only for two resistors, so you add a third resistor in parallel to this, you would add, then it would be 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So that would be 1 over R equivalent. Now let's calculate the R equivalent for the two resistor circuit. So R equivalent would be 1 over R1 plus 1 over R2, which is equal to 1 over R1 R2, then that would be R2 plus R1. So which is R1 R2 divided by R1 plus R2. So we wrote R equivalent is R1 R2 divided by R1 plus R2. Now if you look at this equation, we will see that the R equivalent would be smaller than both R1 and R2. So now let's take an example here and see what the equivalent resistance would be. Let's take an example of a circuit. Say V is 2.4 volts and then you got two resistors across it. This is the V plus minus, and one resistor is a 4 kilo ohms. The other resistor is 6 kilo ohms. Now if we calculate the equivalent resistance of this circuit of the two resistors in parallel, we wrote R equivalent would be R1 R2 divided by R1 plus R2, which would be 4 10 power 3 multiplied by 6 multiplied by 10 power 3. that's the 4 kilo ohms and the 6 kilo ohms, then you would be at 10 multiplied by 10 power 3. That is the R1 plus R2, which would be work out to 10 kilo ohms. So this would be 24 10 power 6 over 10 10 power 3. That would be 2.4 kilo ohms. So 2.4 kilo ohms is the equivalent resistance. Now you look at the total current flowing through this circuit. I would be total V, which is 2.4 volts, divided by 2.4 kilo ohms. You would get 1 milliamp flowing through this. So, and then out of the 1 milliamp, if you want to calculate what flows through this resistor and what flows through this resistor, we can easily find that one. You could just write the I of the 4K is 2.4 volts divided by 4 kilo ohms that would be 600 microamps and or 0.6 milliamps, and I6K would be 2.4 volts divided by 6 kilo ohms, which would be 400 microamps or 0.4 milliamps. Then if you add these two currents, it would add up to the total current, which is 1 milliamp.